So welcome to the core TypeScript concept section in the crash course. Let's start by exploring the fundamental types in TypeScript. These include string, number, boolean, void, null, and undefined. These types are the building blocks of our TypeScript code. So let me type some examples and then I'll explain them. So in my source folder, I'm going to create a file variables.ts that I would be working with. All right, so here in TypeScript file, we define variables using explicit types. For example, username is explicitly a string, user age is a number, and is logged in is a boolean, or true or false. This explicit definition helps to avoid runtime errors by ensuring values adhere to the defined type. The void type is usually used for functions that do not return a value. Null represents the intentional absence of a value, and undefined is for variables that haven't been assigned a value yet. The colon space type part after variable name is called type annotation. Notice how TypeScript uses type annotation to tell the compiler what kind of data we are working with. This ensures that when we use the variable later, the TypeScript compiler can catch any errors if we try to assign an incompatible type. So if I try to assign a string to user age, which is a number, I would automatically get an error, type string is not assignable to type number. All right, let me get rid of it. Okay, next let's talk about type inference. TypeScript is smart enough to automatically infer the types based on the values assigned to the variable, so you don't always have to specify the type explicitly. You see there is no error. In this case, TypeScript knows that the message is a string because we are assigning it a string value right off the bat. However, watch what happens if we try to assign a number to a message. And you see we immediately get a type error. Number is not assignable to type string. If I save, we also get the same error down below because our watch is running. So TypeScript will throw an error here because it inferred the type as string when we first assigned a string value. And now it sees that we are trying to assign a number which doesn't match with the type of the variable. That is true for other types like Boolean and also for types that have been explicitly defined as null or undefined. So if I try to assign not assigned with a value assignment, it would again complain that not assigned is undefined, so you cannot assign it anything. Let me get rid of these. So these were normal type annotations and assignments you would be working with most of the times. But sometimes you need more flexibility with types. Let's look at three special types: any, unknown, and never. So let me type first and then I'll explain. The any type allows you to assign any type of value to the variable. While this gives you complete flexibility, it also removes the safety that TypeScript typically provides, which can be risky and kind of defeats the entire purpose. So better not use it in any practical setting. Moving on. On the other hand, unknown is a safer option. You can assign any type to a variable of type unknown, but before using it, you must perform some kind of type checking. This makes it safer than any because it prevents error at runtime. So let me show you what I mean because it won't make any sense otherwise. So let's say I say console log strict value +1. Now we know it's a number, but we get an error strict value is of type unknown. So it's not letting us use this in console log. What this means that with unknown you still have flexibility. You can assign any type of value, but TypeScript won't let you use the variable until you check what it actually is. This forces you to write safer code. So let's try to use it after checking. So if I say if, see, it allowed me to use it this way. Let me get rid of this. I hope the difference between unknown and any is clear by now. Okay, our next special type is never. So let me type an example. Okay, the never type means a value that will never be returned. This function doesn't return anything, not even undefined, because it always throws an error and immediately stops the program. TypeScript uses never here to tell us you won't get a result from this function. All right, I think this is not a clear example, so let's come up with another. Let me type it first. Though ahead of its time in the course, and we'll get familiar with the syntax later, here we told TypeScript that status can only be success or error. This is called a union type, and pipe symbol means or. So our code is checking the status for its values like success or error and logging appropriate output in if and else if. But note the only possible options are being handled by if and else if clauses. The else clause at the end should never execute because status can only be success or error, which is guaranteed by the colon status type annotation. But just in case someone adds a new option later, like pending to the type, now you see there's a red squiggly appearing here. The never assignment will catch this thing. If TypeScript sees a value here that doesn't belong, it'll throw an error during development. Type pending is not assignable to type never. It is a helpful way to make sure we have handled all possible cases and nothing slips through. Alright, let's now talk about arrays and tuples. In TypeScript, we can define arrays with specific types, which ensures all elements in the array are of the same type. Here, numbers is explicitly typed as a number array, which means all elements in the array must be numbers. TypeScript will throw an error if we try to add something that isn't a number, which in this case it's doing on 7, which is a string. Next, discuss tuples. So tuples are similar to arrays but with a fixed length and specific type for each position. So let me type an example first. Here person is a tuple that expects the first element to be a string and the second to be a number. Trying to switch these types will result in a type error, like you're seeing right now. Alright, next thing is enums. So enums are a great way to define a set of named constants. By default, numeric enums are assigned numbers starting at 0 unless specified. Let me type first and then it would make sense. So in this example, direction.up is 1, direction.down is 2, and so on. This allows for more readable code, especially when working with values that can take on a limited set of possibilities. Enums can also be string-based, which might be useful when the values are meaningful strings rather than numbers. So let me type an example of that too. Here the enum values are strings, making it clear what each status represents. Let me also write a usage example so that we know what we are talking about because enums are an extremely useful feature that you would be using when working with TypeScript. Enum status dot success and the IntelliSense work as well, showing you the values. And we can do a console.log of current status, and this is going to output success in capital. And we can also see how to execute this file while the watch is running. So since everything is being compiled, we can say this slash variables.js, and you can see success being written out to the console as expected. This is useful when you want your code to be both readable and meaningful, especially when sending or receiving data in format like JSON. All right, before this section ends, we have to talk about union and intersection types. So union types allow a variable to hold multiple types. You can combine different types using the pipe operator. You have already seen that example for the status, but let me type it anyway. Okay, here result can be either a string or a number. Both of these are allowed on line 56 and 57. But TypeScript will throw an error if we try to assign it any other type like Boolean, which is not allowed. Our final concept in this section would be intersection types. So intersection types allows you to combine multiple types into one. This can be useful when you need a variable to meet multiple type requirements. That won't make sense until I introduce it as an example. So here employee details is a combination of both person and employee. So employee must have both a name and an ID. This technique using this AND operator is called intersection types. So fantastic work so far. You have just covered TypeScript's core concepts from basic types to more advanced structures. Up next, we'll dive into functions in TypeScript and learn function basics and overloading, followed by advanced function concepts and functional programming techniques.